Now in this class we are going to begin discussion on a very important topic, that is normal distribution. Now when it comes to statistical probability distributions, normal distribution has a great significance in finance. No matter what finance course you are pursuing, if it is an advanced level course, it will bring involvement of lot of statistical applications, and statistical measures of returns will always include the discussion on normal distribution, because it is generally assumed that the distribution is normal. So if there are exceptions to the normal distribution, you have learnt that it could be a possibility that the distribution is not a normal distribution, then the distribution is considered to be having skewness and kurtosis, or any one of them or both of them. Here when I say the distribution is normal, a normal distribution is characterized by a bell-shaped curve. Now that bell-shaped curve will indicate an area, and that area represents probability. So there are two main components of normal distribution: the mean and the standard deviation. So basically you can say normal distribution itself is a function of these two important factors, mean and standard deviation. Now what exactly we are trying to do? Let me give you an example. Suppose I say that a particular stock generates a mean return of 20% with a standard deviation of 5%. And I am asking you, what is the probability that the mean returns will be above 25%? Assuming that the mean returns have a normal distribution. So what I inform to you, three important pieces of information I have given to you. I have given you that the mean returns are normally distributed. That means they will follow all the characteristics of normal distribution. Then I inform to you mean returns. I inform to you what is the standard deviation of the returns. And now I am asking you a question, what is the probability that the returns will be above 25% where the mean returns is just 20%? Is there a possibility? If yes, what will be the probability? If you want to answer this type of questions, you need to bring normal distribution into consideration. So this is going to be a little bigger discussion, and I am going to include lots of examples. Let me throw a possibility that this may not be precisely included as part of your curriculum, but understanding of normal distribution is a mandate for you. Without that, your learning ahead will become little complicated. So let us try to write some notes over here. First of all, under the heading normal distribution, you please write, the normal distribution, also known as Gaussian distribution, is a continuous probability distribution characterized by its bell-shaped curve. It is defined by two parameters, that is the mean, which is symbolized as mu, and the standard deviation. Now just before you write, let me also explain to you one important thing. See, we have learned one thing, that arithmetic mean of say a data where x is the variable, the arithmetic mean is generally resembled as x bar. But when I put forward x bar as the symbol for arithmetic mean, it is the sample mean. If I have to look into the population mean, it is symbolized by mu. So mu is the mean of the population. So please write up this paragraph about normal distribution, and then I take you ahead. Let us move ahead and continue writing further. Key characteristics. Symmetry. The curve is symmetric around the mean. Bell shape. Most of the data points cluster around the mean, creating a peak, and the tails extend infinitely in both the directions. Mean, median and mode. In a normal distribution, these three measures of central tendency are equal. Empirical rule. Approximately 68% of the data falls within one standard deviation of the mean, 95% within 2, and 99.7% within 3. Now, what is the exact significance of this line? I am going to explain to you in detail when the right time comes. Let us move ahead, and now we talk about the mathematical representation. The probability density function, that is PDF, of a normal distribution is given by f, which is the function of x as a variable, mu as the mean, and sigma squared as the variance. Sigma squared is the variance which indicates the squared value of standard deviation. So x is the variable for which you are calculating the probability density, mu is the mean of the distribution, sigma square is the variance of the distribution, where sigma is the standard deviation. Let us move ahead and continue further. Normal distribution, how it would appear. Now this precisely is a bell-shaped curve. I want you to concentrate on this before you start writing. Now the mean is at the center, but do you notice what is happening? The mean is symbolized as 0, which is at the center. What does that mean? That if you find the deviation of x value from the mean, where x itself is the mean, then mean and mean will have 0 deviations. So what you actually find within this entire area is the deviations from the central value. So if I plot these two lines over here, these two lines and these two lines, and identify these values, look at this. This is 1 standard deviation, this is 2 standard deviation, this is 3 standard deviation. This side it is -1 standard deviation, -2 standard deviation, -3 standard deviation. Now though pictorial presentation over here indicates that the area is kind of bounded, but it is never bounded. This extension of this tail on the left and the tail on the right will be to infinite limits. Now let me explain to you one thing, that what you are finding as on the extreme right as well as on the extreme left, these are resembled as tails of the distribution, and this is the peak of the distribution. So the mean, the median and the mode, all three will be equal. That is one important characteristic of the normal distribution. So this may be a little confusing initially, that what is this 1 standard deviation, 2 standard deviation, 3 standard deviation and so on, but I am going to explain this to you systematically, don't worry at all. Now what are we trying to achieve from this diagram? It is basically the presentation of the probability density. That means we would want to find the area of these regions, and the area over here would represent the probability. Now let me tell you, if the entire area within the bell-shaped curve, or what you can call as normal curve, if the entire area is assessed, that entire area will be 1. So if you look at the central point, that is 0, from 0 to this positive 1 standard deviation and from 0 to this negative 1 standard deviation, you will find that the entire area is the same. Now here comes the role of symmetry. The curve, what you see over here, is symmetric at the center. Means what you find from 0 to +1 and from 0 to -1, both will have exactly same area under the curve, because the curve is symmetric. Now this area, what we can find, it is 34.135% approximately. That means the area from 0 to +1 standard deviation, this right side, this part, this block, if you see, the area of this block is 34.135%, that is from 0 to +1 standard deviation. Similarly, from 0, if you go to the left, it will be the area between 0 to -1 standard deviation, and that area is also 34.135%. Because the curve is symmetric to the center, the area to the right and area to the left will be same when the extreme ends is represented as -1 and +1 standard deviation. Now look into one thing. If you take aggregate of both of these areas, it is coming to what? Somewhat 68.27% approximately. So 68.27% will be the combined area from -1 standard deviation to +1 standard deviation. That is where we say 68% area falls within 1 standard deviation. That is from -1 standard deviation to +1 standard deviation. Once again I am telling you, what is the significance of this area? I have yet to talk about that, and we are going to take calculative examples to understand this. So what I want you all to do is that carefully note down this diagram. This will be important for your references ahead. The area from +1 standard deviation to +2 standard deviation, that is this particular area, is 13.59% approximately. Again, because of the symmetry characteristic, exactly same area you will be finding between -1 and -2 standard deviations. Likewise, if you try to find area between 2 standard deviation and 3 standard deviation, or area between -2 standard deviation and -3 standard deviation, these areas will also be same, and these are approximately 2.14% each. So now if you add up all these values, it will be substantially very high probability, almost touching 100%, but not exactly 100%. It will be 99 point something. That something what is left over after 99 point something is the area from +3 standard deviation to the extreme right and -3 standard deviation to the extreme left. Now what is most important, you need to understand the implication of this data which is presented in this diagram, and that understanding is the most important when it comes to application of normal distribution. So let me explain this to you by giving you an example. Let us say in a class having some 300 students, I conduct a test, and suppose the average score or the mean score of the entire class is 70 marks. Now I further report to you that the standard deviation of marks is 10 marks. That means the class has a mean of 70 marks and a standard deviation of 10 marks. Now before you understand what is the implication of this bell-shaped curve for a normal distribution, you need to understand what is the significance of standard deviation. Deviation is the possible movement above or below the mean. So when I say mean marks are 70 marks, 70 marks is at the mean. The actual marks of a student may be below the mean or may be above the mean, correct? how much above or how much below? So on an average, the deviation is 10 marks, means 10 marks above the mean. So 70 plus 10, it will be 80, or 10 marks below the mean. So 70 minus 10, that will be 60. Does that mean that no student would have scored below 60 or no student would have scored above 80? The answer is no, it is not like that. This 10 marks as standard deviation indicates the average deviation. Keep in mind one thing, the way you learned how to determine standard deviation earlier, you should know very clearly that the data set given to you will have wider deviations. The deviation on an average, what is observed is the standard deviation. That means there is a possibility of a student scoring above average, that is above 70 marks to the extent of 80. There is a possibility of a student scoring above 80. There is a possibility of students scoring above 90 as well. The probability will have to be assessed based on the normal distribution. But there is a possibility that the marks of students may be above or below the average. But how much above or below? It could be 1 standard deviation above the average, 2 standard deviations above the average, 3 standard deviations above the average. Now let us try to interpret that. When I say 1 standard deviation above average, means 1 standard deviation in my example is 10 marks. So 10 marks above the mean would be 80 marks. 2 standard deviation means 20 marks above the mean. Correct? 2 standard deviation is 10 marks. 2 standard deviation means 2 times standard deviation above the mean would be 90 marks. That is 70 plus 20. Likewise, if I say 1 standard deviation below the mean, it will be 70 as mean minus 10 marks for 1 standard deviation. Likewise, if it is minus 2 standard deviation, then it is 2 standard deviation below the mean, means 20 marks below the mean, means it will be 50 marks. So now, look at this. At the center lies the mean marks, that is 70 marks. Positive side 1 standard deviation indicates 10 marks above the mean, and negative side 1 standard deviation indicates 10 marks below the mean. That means this range which is marked with this different color, this is the score range between minus 1 standard deviation and plus 1 standard deviation, where mean is 70. Minus 1 standard deviation means 1 standard deviation below the mean. 70 minus 10, 60. Plus 1 indicates 1 standard deviation above the mean. So it will be mean marks plus 10 marks, that is 70 plus 10, 80 marks. Now the question is, how many students fell in this category who have scored 60 to 80 marks? Look at this. 34.135% students would have scored below the mean, but up to this range of 60 marks, means their score range is between 60 and 70 marks. Another 34.135% students would have scored above the mean to the extent of 80 marks, means between 70 and 80 marks. If I combine both of these categories, I will get total number of students or the percentage of students who would have scored between 60 and 80 marks. How many such students? 34.135 plus 34.135, what? 68.27% approximately. So 68.27% students would have scored between 60 and 80 marks. If the mean marks are 70 marks and standard deviation is 10 marks, number of students scoring between 60 and 80 marks will be 68.27% students. I am sure you people are understanding this whole matter. Now let me take you ahead with some further description on the notes. Now here you write normal distribution basics. Imagine you have a lot of test scores that are normally distributed. Most students scored around the average, that is the mean, and fewer students scored very high or very low. The curve looks like a bell with the highest point at the mean. The left and right sides of the curve are mirror images. If the mean test score is 70 and the standard deviation is 10, then 68.27% of students scored between 60 and 80, 95.45% of students scored between 50 and 90, means we are talking about 2 standard deviations below and 2 standard deviations above the mean. Then 99.73% of students scored between 40 and 100, means 3 standard deviation below the mean and 3 standard deviations above the mean. Let us move ahead, and now we write something about Z scores. Z score tells you how many standard deviation a data point is from the mean. So Z value can be computed by taking x minus mu divided by sigma. For example, if a stock's return during a particular period is 20% with a mean of 16% and a standard deviation of 4%, how will you compute Z value? Look at this data. This data indicates that the mean returns are 16%, means 16% resembles mu, and standard deviation is 4%, so sigma is 4, and the returns which were actually observed were 20%. So Z value will be computed by taking 20 minus 16 divided by 4, like this. X minus mu divided by sigma, that is 20 minus 16 divided by 4, that will give you 1. Positive 1 indicates that it is 1 standard deviation above the mean. When I say 1 standard deviation above the mean, you know the idea. Mean returns are 16% and the actual observation indicates that the returns were 1 standard deviation above the mean. 1 standard deviation is equivalent to 4%. So the returns were 4% above the mean. Mean is 16%. 4% more than that would be 16 plus 4, as in 20%. That is the significance of the Z value, and it is the Z value based on which you will be assessing the probabilities over here. So let us write the meaning of this. The return is 1 standard deviation above the mean. Let us move ahead to understand this normal distribution through some examples, and let us take the first example in this sequence. This example conveys the information this way. The returns of a stock are normally distributed with a mean, that is mu, of 20% and standard deviation sigma of 5%. What is the probability that returns will be up to 20%? What is the probability that returns will be above 20%? What is the probability that the returns will be between 20% to 25%? What is the probability that returns will be up to 25%? And what is the probability that the returns will be above 25%? Now when you are handling an example like this, please understand, the mean returns are 20%. So if you can visualize the bell-shaped curve where the center is the mean, that means the center is identified as 0. Why 0? Because 0 is the Z value at the center. 0 is the Z value at the center. So whatever be the data given, if I ask you what is the probability that the return will be up to the extent of mean, so from that mean, that is from the center, you have to go to the extreme left tail, correct? From the center, if you go to the extreme left tail, it is half of the total area within the bell-shaped curve. The total area within the bell-shaped curve represents 1 or 100%. So half of that area will be 0.5 or 50%. Therefore, if I ask you what will be the area falling above the mean, it will be another 50%, because mean is at the center. It is dividing the whole data set into two equal halves. Therefore, the probability of returns to the extent of mean is 50%, and the probability of returns above the mean is also 50%. So, what I want you all to do, I want you all to write up that part of the answer like this. Probability that the returns will be 20% or less. When I say up to 20% means it is 20% or less. Z value will be computed, or Z score will be computed by taking x minus mu divided by standard deviation. Now look at this. X value, what you want, that means the probability that you are finding is for 20% return. That means 20 is the x value. Mu was given as 20 and sigma was given as 5. So when you take 20 minus 20, it itself becomes 0. 0 divided by 5 will give you 0. As a result, when you are drawing this bell-shaped curve, 0 will be at the center. So area from Z equal to 0 to extreme left tail is 50%. Therefore, probability that returns will be 20% or less, that is returns will be up to 20%, will be 0.5 or 50%. Probability that the returns will be above 20% means they are asking you this portion of the area. So the total area is 1, this shaded region is 0.5. So this unshaded region will be the probability that the returns will be above 20, and that will be computed by taking the total area minus the area on the left. So it is 1 minus 0.5, that will be 0.5 or 50%. So the probability that the returns will be above 20% is 50%. Let us move ahead and deal with the next requirement of the question. It is demanding the probability that the returns will be between 20 to 25%. Now we know one thing, that the mean returns are 20%, but now for mean returns as 20%, you have already worked out the Z value. Z value for 20% return will be 0. We will have to work out the Z value for 25% returns. So if a stock return during a particular period is expected to be 25% with a mean of 20% and standard deviation of 5%, how will you compute the Z value? Z will be x minus mu divided by sigma, that will be 25 minus 20 divided by 5. So 25 minus 20 in the numerator you get 5, 5 divided by 5, it is exactly 1. Simple logic is the mean returns are 20% and the possibility of earning the returns as 25% will be 5% above the mean, means it will be 1 standard deviation above the mean, correct? Because 5% above the mean means 1 standard deviation above the mean, because the standard deviation itself is 5%. So now if I identify the bell-shaped curve or the normal curve, the one positive value, that is 1 standard deviation, will come to the right side of 0, right? So I plot that, and we have learned one thing some time back, that this particular area where the Z score is 0 to 1, this strip will have area of 34.135%. So we can write area under normal curve for Z equal to 1 is given as 34.135%. Therefore, the probability that the returns will be between 20 to 25% will be 34.135%. Let us move ahead to the next part of the question, where the question is asking you probability that the returns will be 25% or less. That means the returns should be up to the extent of 25%. Now Z value for 25% return equals to 1. We have just computed in the previous requirement. So where it would lie on the graph, that is under the normal curve. one standard deviation will lie on the right side of 0 or right side of the center, where area from 0 to 1 standard deviation, we have already identified that area as 34.135%, and the area from 0 to the extreme left will be half of the total area, that will be 50%. So, we write cumulative area will be 50% plus 34.135%, and that is 84.135%. What is worth understanding over here? What is important over here? That the possibility of returns between 20 and 25% is this region, correct? This region that was above 20% and up to 25%, that probability is 34.135%. Now, we have already assessed that probability in the previous working. Now, in this particular requirement, we have to address that what is the probability that returns will be up to 25%. Means returns, if it is 20% and above, up to 25%, that is fine. If it is anything less than 20%, that also is fine. So, anything below the mean will have probability of 50%, and this probability of returns above 20% and up to 25% is 34.135%. So, cumulative probability will be aggregate of both of these regions, that will be 50% plus 34.135%. The probability that the returns will be up to 25%, that is 25% or less, is 84.135%. 25% or less means 25% is also included over there. Next part of the question is asking you, what will be the probability that the returns are above 25%? Now, use your common sense. Up to 25%, it is falling within 1 standard deviation, and you are going from the extreme left to 1 standard deviation on the positive side. This cumulative probability is 84.135%. So, can you notice the unshaded area will obviously indicate the probability of returns being above 25%, and that comes to 1 minus 84.135% or 1 minus 0.84135. It will give you 15.865%. So, I am sure you have understood this whole thing very clearly. What I want you all to do is write up the last part of the solution to that example, and ahead I am going to put forward many more examples for your clear understanding. So, let us just write up this part of the solution, and with that I am going to put an end to this session. Thank you very much for attending the class, and don't forget to complete writing this whole thing before you wind up this session.